Hey guys, and welcome to another lesson, the 2019 Kaplan GED book. I'm just going to put this on the screen over here. You can pause it and read this if you like. I'm not going to go through all of this because we are going to go through it when we're actually solving the problems. Okay. Yeah, and I'll kind of explain all this. So if you want, you can pause it and read over that for your own reference. And if you don't understand everything here, it will be explained when we're actually doing the problems, which is on the next page. Okay, right over here. Okay, so to perform operations with fractions, you need to be able to write equal fractions in higher or lower terms. The terms are the numerator and denominator. Okay, so what the numerator is the top number in a fraction. Like, see this 3/4 right here? 3/4. Top one, 3, is the numerator. Bottom one is the denominator, or 2/3. 2 is the numerator, 3 is the denominator. So the terms are the numerator and denominator. A fraction is reduced to lowest terms when the two terms do not have any common factor except for 1. Okay, so when there's no number that can go into 2 and 3, for example, except for 1, then we know this is reduced to the lowest term. Okay, like 2 goes into 2 one time. Does 2 go into 3? No, it doesn't, not evenly. But 1 goes into both of these. 1 goes into 2 two times, 1 goes into 3 three times. However, how this fraction originated, 10 to 15, there are numbers that go into these other than 1. 5, for example. 5 goes into 10 two times. 5 goes into 15 three times, which is actually what they used to reduce this fraction, the number 5. Okay, write the proper fraction for the shaded portion of each figure. Okay, so proper fraction, which you read on the first page, is when the numerator, okay, which is, for example, 19. Did it say proper fraction? Yeah. Okay, so when proper fraction, when the numerator is smaller than the denominator. Okay, an improper fraction would be, well, we'll read that when we get to it. Write a proper fraction for the shaded portion of each figure. So let's see, this complete unit here requires 5 pieces, but we have 3 of those 5 pieces. So how do we tell people that? We have 3 out of 5. Okay. This one here requires 4 pieces, but we have 2 pieces, which again are the shaded areas. So how do you tell people that? 2/4. Just as a side note, anytime the bottom number is double the top number, it means it's 1/2. Okay, and 1/2 can always be reduced to its lowest term, which is, I'm getting a little ahead of myself here, but this will help you remember in the future too. Okay, so these are the same numbers because they're both halves. Okay, this one here requires 3 parts to make a whole, but we only have 2, which is the shaded area. So 2/3. Okay, or 2/3. Erase that. Okay. Let's see, write an improper fraction and a mixed number for the shaded areas. Okay. So an improper fraction for this would be, we have 7 shaded areas, we have 7 pieces, and to require a whole, unit here, you only need 3 pieces. So you would put 7 over 3. Okay. This one here, you need only 2 pieces to make a whole, and we have, again, 7. So 7 over 2. Over here, you need 4, and we have 15 pieces. So 15 over 4. Just to let you know, these are improper fractions. They're improper because the top number is larger than the bottom. Again, top number is larger than the bottom number. This means that you have more than one piece, okay? Because 3 is all you need to make one piece, but you have 7 pieces, okay? I'm saying pieces for both of these terms, but say 3 is how many parts you need to make one whole, and you have 7 pieces, okay? Or 7 parts. So you actually have more than one there. You actually have more than 2, but we'll get into that in a sec. Okay, it also says to write an mixed number, write an improper fraction and a mixed number. Okay, so actually it wants us to do the mixed number anyways. So let's do this. Okay, so basically we have to divide this. So 3 goes into 7. How many times? Well, 2 times, and that equals 6. Okay? But 6 doesn't equal 7 evenly. We have 1 remaining, so we put 1 over 3, because we still keep this. See, this indicates that this is the quantity to make 1. Okay, so since we do have this over, we still do have a remainder, we need to put the indicator that tells how many to equal 1. So, sorry, I actually put 6 there. I meant to put 2. Okay, for example, 3 goes in 7 2 times. There we go, and that is the mixed number for this, showing we have 2 pieces and 1/3 of a piece. Or let's say whole, 2 wholes and 1/3 of a whole. Okay, now this one here, 2 goes into 7. How many times? 3 times. And 3 times 2 is 6, so we know we have 1 remaining. Okay, 1 more to make 7. So we do the same thing. Add the 1 up there and bring the denominator down here. Okay. Again, this one, how many times does 4 go into 15? Well, we know 3 times 4 is 12, and 4 times 4 is 16, so if we go 4, then it's over, so we use 3, and we know it's 12, so we have 3 left over, so we put the 3 here, 3 and 3/4. Okay, so these are improper fractions, mixed numbers. Well, these ones are, this one, and this one, and this one. Okay, the rest are improper fractions. That's when the numerator, top number, is larger than the denominator, the bottom number. Okay, let's move on. I'm not going to do all of these because this would take quite a while, but I will go through several of them to give you the idea. Okay, so for example, write improper fractions as mixed numbers and mixed numbers as improper fractions. So 3/17, that's an improper fraction. So again, how do we do that? 3 goes into 17. How many times? Well, I know 3 times 5 is 15. If we were to go any higher, 3 times 6 would be 18, so it would pass 17. So stick with 3 times 5. 3 times 5 is 15. Okay, so 5. And we have 2 left over from 15, because 17 minus 15 is 2. Okay, so 2 over 3. So this, as a mixed number, is 5. We know we have 5 wholes and 2/3 remaining. Okay, that's pretty much the same thing as that, so we'll keep it moving. Let's try this one over here. 9 over 43. 9 goes into 43. Well, 4 times 9 is 36. If we were to go 5 times 9 would be 45, so we'd go over, so we'll stick with 4. Okay, 4. And how many left over? So 36. 43 minus 36. Let's go ahead. You could actually just do this in your head, but for the sake of it. 43, 36. Okay, 3. So basically, can 3 take 6 away from 3? No. So borrow from there and make this 4 a 3 and make this a 13. 13 minus 6 is 7. 3 minus 3 is 0. Okay, so we have 7 remaining. So 4 and 7 over 9. Okay, because remember, you keep the denominator. Okay, let's try a different one. Let's change some mixed numbers into improper fractions now. This is quite easy as well. Let's do this one. 5 and 2 over 9. So what you do always for mixed numbers is you multiply these two. Okay, so 9 times 5 is 45. Okay, then you add 2. 46, 47. So we know that we have, let's see, what are we changing that to? Improper fractions, mixed numbers to improper fractions. So here is our improper fraction. Always keep the denominator, okay? So this pretty much here lets us know that we have 5 wholes, 5 whole units, with 2 left over, okay? Well, let's say 2 of the 9 left over. Okay, so let's do one more of those mixed numbers. Again, so we have, let's do this one, 2 and 5 over 12. So 2 times 12 is 24. And, yeah, 2 times 12, sorry. 2 times 12 is 24. Then add the 5, 29. Over 12. Okay. When I was doing it the other way, I added this, but that's unnecessary. So, okay, lets you know that this equals this. 2 parts with 5 remaining over 12. Alright, so now let's do this. Write an equal fraction with the given denominators. Okay, so for example here, what you do is, since basically what you're trying to do is increase this fraction. So you're trying to write 3/4 as a larger number, okay? Nevertheless, just because it's larger, they'll still equal the same amount, okay? For example, 4 times what is 16? 4 times 4 is 16. So 3, basically you will need to multiply 3 by the same amount that you multiplied 4 to get 16 to maintain its even integrity so that we know it stays even. So 4 times 4 is 16, 3 times 4 is 12. So you would have 12 over 16, okay? And that would equal the same as 3/4. Let me erase a little bit of this here. It's for another way to look at it too is if you had 100, if you had 10 pieces out of 100. Since these are even numbers, well, the other ones were too, but these are easier to spot. 10 out of 100. See, 10 over 100 is 10%. This is 10% of 100, which is the same as this. 1 over 10 is 1 is 10% of 10, okay? So the percentages are the same. As long as the percentages are the same, essentially it's the same amount. Okay, so let's see, we'll do a couple more of these. So 3 times what? 3 times 7 is 21. So 1 times 7 is 7. So that would be 7 over 21, which would equal 1/3. Okay, because 7 parts, 3 sevens would equal 21. So 7 is 1 part, or 1/3 of 21. Okay. This one here, 5 times what is 60? 5 times 12 is 60. So 4 times 12, 2 times 4 is 24, so 48. 48 over 60 would be your answer. And remember, we multiplied them both by the same number so that we keep them exact same proportions. 8 times 5 is 40. 3 times 5 is 15. So 15 over 40 is equal to 3 over 8. 25 times 4 is 100. 25 times 4 is 100. 6 times 4 is 24. So 24 over 100 is the same as 6 over 25. Reduce each fraction to lowest terms. Okay, reduce each fraction to lowest terms. 21 over 28. So what we need to do is find the highest number here that goes into both of these and divide them. Finding the highest is actually the easiest way to do it. It makes it a one-step process. Otherwise, you can pick any number that goes into them that's lesser than them, but you may just have to break down the steps a few more times. We know that 7 goes into 21 3 times, okay? And we know that 7 goes into 28 as well. So let's just set this up all pretty like. Okay, there we have it. 7 goes into 21 3 times. 7 goes into 28 4 times. Okay, so 21 over 28 is equal to 3/4. Okay. And remember, that's when you are reducing fractions. Okay, when you're actually increasing fractions, you'll actually multiply them. Okay, let's see. erase that. I'll do another one of those for you. Okay, 12 over 20. 12 over 20. What's a number that goes into both of them evenly? Again, the highest number is the best. If not, that's okay. Choose any number. For example, we know that 2 will go into 12, and we know that 2 goes into 20, because 2 times 10 is 20, and 2 times 6 is 12. So let's use that example. Okay, 2. So 2 goes into 12 6 times. 2 goes into 20 10 times. Okay, that was division we were doing. And remember up here that it said when you're reducing fractions, when 1 is the only number that can go into the reduced fraction, you know you have gone as small as you can. But in this case, there's still a number that goes into both of these that is higher than 1, and that number is 2. 2 goes into 6 3 times. Okay, 2 goes into 10 5 times. So when you're reducing to lowest terms, you would have to continue doing this until you have the lowest one. Now, for example, does any number go into 3/5 other than 1? 2 goes into 3, not evenly. 2 goes into 5, not evenly. 3 goes into 3, yes, 1. 3 goes into 5, no, not evenly. So, yeah, it's reduced to lowest terms, which would be 3/5. So 12, 20. 12 over 20 is equal to 3/5. Let's do one last one. 60 over 90. I'm not sure why I'm picking the largest number, making it hard on myself. Okay, again, I do know that 10 goes into 60. Okay, I know that 10 goes into both of these. It's probably another number that does as well, but we will see. Sorry. I'm not sure why I'm keeping that pushed down. Here we go, division. Okay, so 10 goes into 60. Well, let me just write this whole thing. 10 goes into 60 6 times. 10 goes into 90 9 times. Okay, is there a number, let's keep reducing, is there a number that can go into 6 and 9? Yes, 3 does. So 3 goes into 6 2 times. Then 3 goes into 9 3 times. So we reduced it to even less. 2/3, okay? So 2/3 would be your answer as far as reducing it to the lowest terms. So that tells us right there, actually, because since we divided it by 10, and when we did that, it wasn't at its lowest point. That tells us there's actually another number that goes into another number that's higher than this that goes into both of these as well. So keep that in mind. Okay, so for the last couple here, 18 out of every 24 people surveyed say they went to at least one movie in December. What fraction of people surveyed went to at least one movie in December? So we know that the total amount of people that they surveyed was 24, and 18 of them had gone to at least one movie. Okay, so choose the best answer. Okay, so this number here is the same as one of these numbers here, so you have to figure that out, which, as you can see, this is reduced. So which number goes into 18? I know 6 goes into 18 3 times. Does 6 go into 24? Yes, it does. Okay, That's why it's good to know your multiplication off the top of your head, just because you can do this a lot quicker. So we're going to use 6 for both of these, and I'm pretty sure 6 is the highest number too. That can go to both of those. So let's put our division symbol. 6 goes into 18 3 times. 6 goes into 24 4 times. Okay, and really the only number that goes into both of these numbers now evenly is 1. So we know we have reduced to the greatest degree. So 3/4 is your answer, which is A. Which of the following fractions equals 2/5? So this is a little bit different than what we've done. So 2/5. So we know that 5, okay, look at all our answers here. We know that 5 equals 100 because it's trying to get us to change it to one of these numbers, and they all have 100 there. So 5 is equal to 100. That's a variable that we do know. We use that to find the variable we don't know, and this is always how it is with this type of problem. You're trying to increase it. So we know 5 times what is 100? 5 times 20. Okay? 5 times 20 is 100. So to keep this the same, proportion as this over here, we need to multiply this by the same amount too. Okay, so 2 times 20 is 40. Okay, so essentially 2/5 is 40 over 100. Same thing, just reduced and not reduced. So that would be your answer there, C. Anyways, that concludes this lesson. Thank you guys very much. Again, if you liked it, did help you, please subscribe, click the like button, tell a friend that's doing the GED as well, and we will be back for another lesson tomorrow. Thank you.